Hello, my name is Mauricio Ranova. My friends call me Mao. I'm a data scientist and machine learning engineer. Today I'm going to show you a Kaggle competition called the Titanic.
This is my profile. You can see my ranking. Then you go to compete. Then you search for the Titanic competition. I have it here. Here you can read the overview, the data, and the notebooks. And then you click on new notebook. Here I have the notebook that I created for you. I wrote a small introduction. This is my first Kaggle competition. The goal here is to predict which passengers survived the shipwreck using passenger data like name, age, gender, socioeconomic status, number of siblings or spouses, number of parents or children. The data has been split between training set and testing set. I created a simplified version for this tutorial designed for beginners with the intention of not giving away my entire solution and to motivate you to create your own exploratory data analysis. I am importing NumPy for linear algebra and Pandas for data processing. Identify the problem, which means gather all the information without making any changes. So here I am importing the training set and then use the shape to identify the number of rows and columns. Same thing for the test set. In the info I can see that there are columns type integer, type float, and type object. I need to change those objects into numeric values so I can do the machine learning. Here I can see the count, mean, standard deviation, the 25, 50, and 75% and the max value of each column. Here I am looking at the missing values because I'm gonna have to do something about these missing values to be able to work with. So I'm focusing on age, cabin, embarked, fare. And I'm looking at the number of siblings and spouses, how many unique values we have. They go from 1 to 8, and parent and children goes from 0 to 6. This is going to be important for large families. Explore your options. Here is when I start making changes. First, data cleaning. I'm going to drop unnecessary columns that I won't personally be using, like passenger ID, name, ticket, and cabin, in training and testing set. I convert sex from string to numeric, male 0, female 1. And age, I'm going to replace the missing values with number 30, which is the most common value, mouth. I could use mean or median, but I chose this one personally. Here I'm going to fill the missing values of embarked with S, which means Southampton. And then at the end I have to change fair for the median value. Yeah, I don't have any more missing values. I'm going to change fair from float to integer. I'm going to do binding to the age column, which means I'm going to put them in bins from 1 to 7, then 8 to 14, 15 to 17, and so on, so I can use them more wisely. I'm going to create the columns C and Q with embarked values, and then I'm going to drop the S because it doesn't make a difference in my experience. I confirm that the number of rows is correct, that I didn't miss any rows doing these changes in data cleaning. Then I start doing train, test, and split to prevent overfitting, which means that when you're doing a model in the training set, then you use it on the testing set to make sure that the patterns and tendencies that you found are not too overfitting, which means that the tendencies are more representative. Here I am creating a new column called family by doing the sum of parent-child and sibling spouses, because it's easier to manage like this. I'll tell you why. Because here I'm going to create another column called large family, where if you have more than 4 in your family, then I'm going to call it a large family. And it's going to be either yes or no. It's a large family, yes or no, like here. And then family is going to be just 0 or 1 to differentiate those that travel alone and those that have a family. Here you can see it. Then I'm drop the columns siblings and parent child. I confirm that family can be alone or in family, and large can be either large family or not. Here I'm going to do machine learning. I'm going to use the algorithm of logistic regression. I'm going to do, I want to create a model, then I'm going to fit X and Y. I'm going to use the model to predict using the test data, dropping the passenger ID. And then with white breadth, I can do I can get the score, so I can compare if logistic regression do better than other algorithms. And here with white breadth I get the output. This is the file that I'm going to be at the end submitting as a result of the competition, where I can see which one survived and which didn't. So here I can see that with logistic regression, in the training set, test set I have 82%, on the test set I have 74%. I can see that according to this, nobody survived on the first 5 rows. So this was not really good, but we'll see the other algorithms. On SVC, support vector control, I have a bigger percentage of people that survive, but it's still in the 60s. It's not the best. On K-neighbors, nearest neighbor classifier, again didn't survive anybody. This looks better. On random forest I have a 25% of survivors with a 92% in training and 82% in testing. This is the best so far. Decision tree gets a little closer, but it's not as good as the random forest, so I guess random forest was the best for this scenario. So here I'm doing a comparison. I'm creating a plot with MatPlotLib where I can see clearly that random forest did better than the others, 82%. So I do a if conditions to select the strongest one. In this case I can compare that the random forest was the best of all of them, and that's what I'm gonna show you here. How many rows, the head. I can see that, for example, this one survived, and this one survived. I'm gonna export the file to a CSV file that I can submit. And in conclusion, men traveling alone were less likely to survive. Couples and families were more likely to survive together or sink together. Large families may have struggled to fit all together in a lifeboat, so they have waited for the next boat and the next boat, indefinitely postponement that made it harder for them to survive. The output is in this file, output. I can download it and then go to overview, submit prediction, drag my file from here, give it some description, and make a submission. Ta-da!
In conclusion, men that travel alone are less likely to survive, and families either survive together or sink together. Thank you. Bye.